Hey, hi everyone. Welcome back to live stream session with Axiom Interns. We are conducting a series of presentations of Axiom Interns teams. They are developing white label applications right from the healthcare, hospitality, real estate, garments, and many more. As there are many teams working on, so to conclude every presentation in one stream wasn't possible. So we divide these streams into various parts. So today with Axiom Entrance team, I'll brief you what exactly they are going to present. The agenda of this stream is to develop a administrative dashboard, right? Not exactly the administrative dashboard, but all the dashboards. First of all, they'll be identifying what are the various users involved in the system, considering administrator is a super user, which will be able to create the privilege based user based access mechanism, and they'll create the users after identifying what are the various internal users and external users. So once user able to log into the system, they'll be redirecting to the UI, and that UI is called as dashboard. So what are the various significance of administrative dashboard? What are the significance of various users dashboard? Because they are actually navigating to to the entire system through the dashboard. So for producing dashboard, how Axiom Interest team are going to manage the entire full stack operation, right from the understanding the user stories for the acceptance criteria, designs, front-end development, database structure development, API development, and integrating all these together and testing it for 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 the performance of for the acceptance criteria of that particular user story. So this is what all presentations involved in. So let's hand over this session to Exam Central's team, and they'll be presenting this administrative dashboard or dashboard creations for the various users in the full stack developmental approach. Over to Exam Central's team.
Good morning, everyone. Today I am going to present our project Travel IQ. Travel IQ is an AI powered travel intelligence platform. The main objective of this project is to simplify travel planning through a smart web application that provides essential travel information in one place. Instead of visiting multiple websites, user can access destination, hotels, travel packages, and AI-powered recommendation from a single platform. The platform enhances the travel experience by providing intelligent and data-driven travel insights. For developing the project, we use React.js for the front-end, Node.js with MySQL Database, and Express.js for the backend. The project consists of four major modules. First, user application, admin dashboard, backend APIs, and database. All these modules work together to provide a smooth travel experience. Now, let me explain the architecture of our project. Our project follows a three-tier architecture. The first layer is the front end, developed using React.js. It provides the user interface where user interact with the application. The second layer is the backend, developed using Express.js, REST APIs. It processes user requests, applies business logic, and communicates with the database. The third layer is the database, where MySQL stores all project data securely. The workflow is: first, user or admin sends a request. The request goes to the backend APIs. The backend communicates with the database. Finally, the process response is returned to the user. The architecture makes our application scalable, secure, and easy to maintain. Now, let's move to the user application. User application shows the features available for the user. The first feature is user sign up and login, which allows user to create an account and securely access the platform. The second feature is explore destination, where user can browse different travel destinations. The third feature is compare destinations, which help user compare multiple destinations before planning a trip. The next feature is AI Assistant, which provides intelligent travel suggestion and guidance. User can also manage their personal information through the user profile section. The main component of the application are navbar for easy to navigation, search option to find destination quickly, destination cards to display travel information, footer containing additional links and information. These features make the application simple, interactive, and user friendly. Now, I will explain the admin dashboard. The admin dashboard is used to manage the entire platform efficiently. The dashboard provides an overview of platform activities. Through user management, the admin can manage user account. Using destination management, the admin can add, edit, or remove destinations. Through hotel management, hotel information can be updated. Using package management, travel packages can be created and managed. The main purpose of the admin dashboard is to manage all platform data efficiently and ensure users always receive update information. Now, let's understand the backend architecture. Our backend is based on the MVC architecture, which stands for Model, View, and Controller. The routes receive requests from the front end. The controller processes the request and implement the business logic. The model interacts with MySQL database. The middleware performs additional tasks like authentication and request validation. The database stores all application data. The responsibilities of the backend are processing our request, executing business logic, returning responses in JSON format to the front end. Now let's look at the database. We use the MySQL database to store all project data. The main tables are user, destination, hotel, package, and bookings. Using this table, all travel information is organized properly. The benefit of using MySQL are organized data storage, faster data retrieval, easy management and maintenance. This helps improve the overall performance of the application. Now, I will explain the REST APIs. Our project uses REST API for communication between the front-end and back-end. The authentication APIs include sign up, login, logout, forgot password, delete account. The CRUD APIs are used available for user, hotel, destination, packages, and bookings. These API perform create, read, update, and delete operations, making data management efficient. After developing the APIs, we tested them using Postman. We used Postman to test all our REST APIs. Using Postman, we tested GET request to retrieve data, POST request to create new data, PUT request to update existing data, delete request to remove data. We also verified request body, API responses, HTTP status codes. This ensures that every API was working correctly and reliably. Now let's understand the overall project workflow. These slides explain the complete workflow of the Travel IQ platform. A, a user first accesses the application and perform an action such as searching for destination, or booking a package. The request is sent to the backend through REST API. The backend processes the request and communicates with the MySQL database. The request, the required data is then returned to the frontend and displayed to the user. The workflow ensures smooth communication between frontend, backend, and database. Finally, let me conclude the presentation. In conclusion, Travel IQ is a complete full stack web application. Our key achievements include building a full stack web application, implementing MVC architecture, developing REST APIs, integrating MySQL database, testing APIs using Postman. For future scope, we plan to implement JWT authentication, OTP verification, AI-based recommendations, payment gateway integration, and cloud deployment. These improvements will make the platform more secure, intelligent, and scalable. Thank you for your attention. Now, I would like to hand over to my teammate for project demonstration.
Thank you, Pratiksha. Now I will briefly explain the admin module for travel panel. Uh, this is the site that lets company staff manages users, bookings, refund, pricing, intelligence, and more from the dashboard. This is the session I walked through five things: front-end design of the admin panel, how it's actually built, how the backend routes are structured, how I check the database connected, how the front-end talk to the backend through APIs, and finally I threw sign up, login, logout, forgot, password APIs one by one. Now let's start the front end. I admin panel as a React built wide and structured around a handful of core components: header, sidebar, login, sign up, and big view, and file that holds every screen, dashboard, user, bookings, refunds, and so on. The design flows: classic admin dashboard, layout of fixed sidebar. On the left of a navigation bar, header on top for each. One second. Its handful core components are header, sidebar, login, sign up, and big views file that holds every screen, dashboard, user, banking, refund, and so on. The design flows: a classic admin dashboard, layout, a fixed sidebar. On the left for navigation, a header on top of each search and account action, and two main content area on the right that swap view and depend on the which tab is active. I am not reloading the page when I switch tabs. Active tabs is just a piece React state, and the content areas render based on the that state. That's what makes it feel like a real application instead of a stack of separate web pages. Open the Admin Travel IQ platform, open Travel IQ folder, and now let's go module by module through the admin front end. This shows the component is sidebar.js. The sidebar is grouped into section instead of one long flat list, which keep it readable as the group through I will organize it as main management intelligence platform. Each item has a ID or label and icon from Lucid React. When an admin clicks and items, it calls on tab changes, which updates active tab back in main.jsx notification every carry a live batches count. So sidebar isn't just navigation, is also status at glance. Now I will see other components are login sign up before an admin every sees the dashboard. It is a screen. It handles both login and sign up in one component. Does basis client side validation and on successful login calls handle login success in main.jsx, such as store the admin session in local storage under key travel admin. That that simple approach for production ID move is the proper token based session, but demonstrating the app end to end. It works well and keeps the admin logged in across page refresh. Now we'll see the other C component, dashboard and view. Components are view.js. This one file holds every screen. The slide bar can navigate it to dashboard view, user view, bookings, refund, price intelligence, AI analytics, and security view and settings, and also more. Each view is its export component. So main.js just picks the right one to render based on active tab. It's big file because it is entire content library to admin panel, but each individual view stay focused on one job. Checking now let's flip over the backend and actual verify two things live are roots verified correctly and its MySQL actually connected. Step ones are looking how roots are registered. In index.js is a registered two roots groups. App.use API auth roots, and second is API.use API slash employee roots. So every endpoint inside auth roots.js lives under API auths, and everything's in employee roots.js lives under, as I also along every incoming request with request method and request original URL. So when I click something on the front end, I can watch the terminal and see exactly which route got hits. That is the fastest the debug and 404 lives. Step 2. In this step, we will confirm the database is connected or not. I will now small debug endpoint specifically for this. First is a get API database status. This is select database. This runs the select database through the connection pool. If MySQL is reachable, it returns connect the true database and database name. If the credential for host in my environment are wrong, this route through and my global error handles catches the returns is 500 with the actual error message. So never I never have guys guess why the connection failed. Second is get API database tables. This is sh- this run are shows tables as a lets everything currently is the database, and so on. I will I will open right now and hits both the lives so as a see the actual JSON response and confirm database is really connected, not assume. Now I will to the API connected in the front end. Now let's connect the dot between the front end and back end in main.js. Access is a user URL comes from the environment variable, and constant API URL input meta environment URL. That means I am not hard coded anywhere. I can point with different backend, just changing environment file and matter. For example, fetch user sends a get request or load data, and it run inside user effect as it fires automatically. Movement the dashboard, and I don't click the anything first. Let's go through actual authentication routes in uh, connect the APIs one to one at time. So sign up API is used to be method use is a post, and endpoint is API auth sign up. Let's send the full name is Santosh Agrawal, and email is santosh12 at the rate gmail.com, and company name is Axiom. Next is the password at the rate 123. This is the brackets complete. First I will explain the sign up API. The API is used to register a new employee on the Travel IQ platform. The front end sends the employees full names, emails, company names, and password to the backend. The backend first validates the input, then checks whether the email already exists the database. If the user is new, the password encrypted using decrypts before using store MySQL. If the email already exists, the API returns the message user already exists, and but the user registered successfully. And now is a login API used to be method is post endpoint is API slash auth slash login, and request body to uh, postman bracket is email santosh12 at gmail.com, and password is password at the rate 123. The login API is used to authenticate user when the user enters their register registered email and password. The front end sends these details to backend. The backend verifies where the email exists and compares the entire password with the encrypted password. Store the database using decrypt. Then user is explain. User ID is 10019, and full name is Santosh Agrawal, and email address are Santosh at the rate. And message is login successfully, and is just login great. And then logout is the method are used post, and endpoint is API slash auth slash logout, and request body is blank. This is the logout API is responsible for signing the user out of the application. Once the API is called, the backend clears the user active session or authentication token. This prevents the user from access protected resource until they log in. Again, help maintain the application security. Now send this request to message logout successfully. And next is uh, forgot password API. Used to be a method used to be post and endpoint is API auth forgot password. Request to the body is bracket email santosh@gmail.com, this email address. The forgot password APIs helps user recover access to their account if they forgot their password. The user enters registered email address and the backend checks whether it exists the database. If the email is valid, a password reset link or OTP is sent to the registered email, allowing the user to securely create a new password. Send this request to messages password update successfully and securely update and password update successfully. Now next is delete account API. Method is used to be delete and endpoints of this API slash or slash delete account request to the body. uh, like it is the email santosh12@gmail.com, this email address. The delete account APIs is used when a user went to permanently remove their account from the Travel IQ platform. The frontend sends the user registered email to the backend. After verify the user identity, the backend deletes the accounts and associated data from the database. This action permanently removes the user access to the application. Now send these requests are a message is account deleted successfully and delete this account. Now API testing is before API testing is overall 5 of this past postman. Did I have move on the connecting the front end forms? That order matters because slotted backend works and front end works instead of a debugging both at once. And now I updated the project folder structure. Project folder structure is backend folder. This Express REST API, backend. These Express REST APIs, and next is a index.js file API entry point middleware dynamic tables and routes, and database is a MySQL connection to connect it the MySQL to, and routes is a sign up, login, and logout, delete account. Forgot password is a two routes, employee routes.js and customer routes.js. Employee leads is a plus register, and customer routes is a CRM style customer CRUDs. And Postman is API collection and manually testing. Environment is a DB host and DB database port and database user. And see this page to log in and log out. The, this is a login page. Uh, First of all, this email ID is santosh12@gmail.com, and then password is used and authentication. First of all, sign up this page for forgot their password. This forgot is Santosh at the rate, first of all email address, then new password is uh, email ID is not, but one solution. Let me check. Solution and email address is, and new password is, corrected password are used, updated message. Okay. Now this is five authentication of APIs used to create the account. First five names Santosh, and add admin email address, and company name are use Axiom, and password is, and confirm password is, condition are terms and condition agree, already exist. Yes, already exist. Yes, already. To close, out, let's done one full pass connecting the UPI, UI and backend for the single action, adding the employee so as entire chain in one go. This is five API sign, logout, forward, and password, delete account work together to manage the complete user authentication flow, the travel IQ. With this, I will work through the admin, front end, and backend structure and database connectivity, all five authentication APIs, and how tested the Postman before integrated them into the UI. Now I will like hand over to my teammate, summarize an overall project, walk through the current integration status, user app. Thank you.
Thank you, Himanshu. Yeah, so as we come to the end of our Travel IQ project demonstration, I would like to briefly summarize what we have presented today. We started by introducing the Travel IQ platform, its objectives, and the real world problems it aims to solve. We then explained the overall system architecture, technology stacks, and the database design that support our application. So next, we demonstrated the admin module, including its user interface and workflow. We also explained the backend architecture, database connectivity, and the authentication APIs developed using the Node.js, Express.js, and the MySQL as a database. Finally, we verified these APIs through live testing in Postman to ensure they are working correctly. So currently, the admin module has been successfully integrated with the backend. So features as such, employee registration, login, logout, password, and the account deletion or management are fully functional. So our next step is to integrate these backend services with the user module which is currently under development. So once we complete it, users will be able to access all the platforms features through our front end seamlessly. So this project has given us valuable hands-on experience in full stack development. So REST API development, database management, backend integration, and team collaboration. So most importantly, it helped us understand how the front end, back end APIs and database work together to build a complete and scalable application. With this, we can conclude our Travel IQ project demonstration. So we hope this presentation has given you the clear understanding of our project's design, its implementation, and current progress. On behalf of our entire team, I would like to sincerely thank you, the respected team members, mentors, and everyone present here for your continuous guidance and support and for your valuable time. So now with your permission, I would like to handle to the other teammates that they can explain their white label project. Thank you once again. Have a wonderful day.
Good afternoon, everyone. Today, we are going to present our project Food Mitra, a smart food delivery and restaurant management platform. Food Mitra is designed to create a single digital platform where customers, restaurant vendors, and administrators can interact efficiently. The platform not only allows customers to order food but also helps restaurants owners to manage their daily operations while giving administrators complete control over the platform. Our project focuses on making food ordering faster, smarter, and more personalized by integrating AI-powered recommendations, real-time tracking, and business analytics. Throughout this presentation, we will explain the architecture, technology stack, different modules, AI features, and finally demonstrate the working of the application. Here is the roadmap of today's presentation. We will begin by understanding the problem that currently exists in online food delivery system and how Food Mitra provides an effective solution. Then we will see the overall architecture of our system and the technologies used to build it. After that, we will discuss the three major modules of our platform: the admin module, vendor module, and customer module. Next, we will see our analytics dashboard and AI-powered features that makes our platform unique. Finally, we will demonstrate the complete workflow of the application and conclude the future enhancement planned for Food Mitra. Before developing Food Mitra, we identified several common challenges in existing food delivery platforms. From the customer's perspective, choosing the right food is often difficult because recommendations are mostly generic rather than personalized. Users also find it difficult to identify healthy food options based on the dietary preferences. Restaurant owners struggle with managing incoming orders, tracking inventory, handling customer feedback, and monitoring business performance through meaningful analytics. On the administrative side, managing multiple restaurants, approving vendors, monitoring orders, and tracking platform revenue manually becomes time-consuming and inefficient. To solve these challenges, we designed Food Mitra as an integrated platform that provides intelligent recommendations, centralized management, and real-time analytics for all stakeholders. Let's see the overall solution architecture of Food Mitra. Our platform consists of the three main portals connected through a shared backend. The customer portal allows users to browse restaurants, place orders, track deliveries, and give ratings and reviews. The vendor portal helps restaurant owners manage their menus, process orders, track revenue, and view customer feedback. The admin portal is responsible for user management, analytics, commission management, and approving vendors to ensure smooth platform operations. At the center is the shared backend, which connects all three portals, manages data, handles authentication, and keeps everything synchronized in real time. This architecture makes FoodMitra organized, scalable, and provides a seamless experience for customers, vendors, and administrators. Now, let's understand how the three main portals of FoodMitra are connected. Our application follows a client-server architecture. The front end consists of the three different interfaces: the customer application, vendor dashboard, and admin dashboard. Whenever a user performs an action such as logging in or placing an order, the request is sent to our backend developed using Node.js and Express.js. The backend processes the request, applies business logics, communicates with the PostgreSQL database, and sends the appropriate response back to the front end. User authentication is handled using JWT tokens to ensure secure access, while cloud storage integration allows efficient storage and management of required data. This modular architecture keeps the application secure, scalable, and easy to maintain. The development of FoodMitra involved several modern technologies. For designing responsive user interfaces, we use HTML, Bootstrap, JavaScript, and React. The backend is developed using Node.js and Express.js, which efficiently handle API request and business logic. We use PostgreSQL as our relational database for storing user information, restaurant details, menus, and order data. JWT provides secure authentication and authorization, ensuring only authenticated users can access protected resources. GitHub was used for version control and team collaboration, while Figma helped us design the application's user interface before development. Together, these technologies helped us build a scalable, secure, and user-friendly application. The admin module serves as the central control system of the entire platform. Through this dashboard, administrators can monitor platform activities in real time and ensure smooth operation. They can approve or reject restaurant registrations, manage user accounts, monitor ongoing and completed orders, track platform revenue, and manage commission settings. The dashboard also provides reports and analytics that helps administrators understand business growth, customer activity, and vendor performance. This centralized management system reduces manual work and improves operational efficiency. The vendor module is designed specifically for restaurant owners. After logging in, vendors can manage their restaurant profile, update menus, change food prices, and monitor inventory availability. Whenever a customer places an order, the vendor receives an instant notification and can either accept or reject the order. Accepted orders are moved to the kitchen queue and where the preparation begins. The dashboard also provides revenue statistics, customer reviews, delivery status, promotional offers, and sales reports. These features help restaurant owners improve service quality, manage operations efficiently, and increase profitability. The next is the customer module, which focus on providing a simple, fast, and personalized ordering experience. Customers can browse nearby restaurants, explore menus, and search for dishes according to their preferences. After selecting food items, they can securely place orders and complete payments through the platform. The application also provides real-time delivery tracking, allowing customers to monitor the status of the order from preparation to delivery. Additional features include wish lists, order history, customer ratings, reviews, and AI-powered food recommendations. that suggest meals based on user preferences and behavior. One of the important features of FoodMitra is the vendor analytics dashboard. Instead of simply displaying orders, the dashboard provides valuable business insights. Restaurant owners can instantly view pending, completed, and cancelled orders. They can monitor average customer ratings, total revenue granted, average food preparation time, and identify the top selling dishes. These performance indicators help vendors analyze customer demand, improving service quality, and make data-driven business decisions. The artificial intelligence is one of the major highlights of FoodMitra. Our food-based, our mood-based food recommendation system suggests meals according to the user's mood and preferences, making food selection easier. Demand prediction analysis previous ordering patterns to estimate future demand, helping vendors maintain sufficient inventory and reduce food wastage. The AI sales analytics features provides insights into sales trends and customer behavior. Healthy food filters help users quickly find nutritious meal options based on dietary preferences. The restaurant recommendation engine suggests restaurants based on user interest and previous orders. Finally, smart subscription plans analyze customer behavior and recommend suitable membership plans, creating a more personalized experience. To give you a better understanding of how our platform functions in a real-world scenario, we will now move on to the live demonstration. My teammate will showcase the complete workflow of FoodMitra from customer logging and food ordering to vendor processing and administrative monitoring. Over to you.
Thanks, Dia. Today I will show you the complete Food Mitra systems end to end. One backend providing three separate front ends, an admin panel and vendor panel, and a customer app. I'll do every step twice, once directly through the API, so you can see exactly what happening um, on the wire. And once through the actual front-end UI. After each step, we will open Prisma Studio to prove the data really landed in the database. Um, Firstly, um, I'll show you. I'll show you the initial frameworks of our in Figma. Uh, this is our frameworks. After deep analysis, we have created this UI uh, for a user side. Um, Here it has a login. It has map. This is the UI which we have initially created. Um, Now we can go through the front ends which we have, and I'll show you the three main modules which firstly is admin, then vendor, and lastly the user. This is the uh, latest new interface as per our recommendation. uh, First, firstly we run this module by going the terminal, with the help of npm run dev. This starts our express server on port 3000. Every request from three front end, and the postman goes through the single backend. um, before bef- before Before anyone can log in, the system needs to list one admin account. We need to create through the public sign up form. uh, uh, we don't need to create this through the public sign up form. For security, admin are seeded directly using script. um, we then you can see here, uh, this script checks the admin with the email already exists, and if not, hashes a hashes a password with a bcrypt and insert a new row into a table using Prisma Studio. um, Here we goes in admin. It has already super admin with its email and the role and the active status. uh, Notice the password isn't stored as a as a plain text. It hashes even if someone access the database directly, they can't read the real password. um, Now I'll let's logged in as a admin through the raw API first. um, Now we goes in admin module folder, then goes in auth folder, and then we open the admin login file. um, Here in the body I already put the put email and the password which we have um, in the file, like the admin @foodmitra.com, and its password will be admin @123. After sending this, it's so is so the success. uh, we can we can You can see here it has the tokens and the ID. um, then the backend verifies the password against the bcrypt hash, then issue of jwd access the token. Postman takes script automatically capture this token and save it as a admin access token in our environment. So every other admin request is this a collection of new authorized automatically. Um, Now I will show you the front end. This is our admin front end. uh, Here you can see the login page. We don't need external or email address. We have already the email address. uh, we just paste here and its password also. Same request, same backend, same JWD, just triggered by a button click instead of Postman. You can see the admin dashboard load. This data is coming from Get API, the same kind of call we just made manually. Now we can see the vendor sign up. Uh, so we have to go in vendor module folder, then the auth folder, and then we goes in vendor sign up. Here uh, here I have already added data for for convenience of our time. So now I'll send it. It gives us success, the APIs run, and it gives us the ID, uh, which we have to copy it. Then behind the scene, three things just happened. A vendor row was created with a status pending. A restaurant row was created currently closed, invisible to customer, and the uploaded KYC documents were saved and linked in the vendor document. Um, Now I'll show you the front end. Um, Here we just sign up as a regular as we can. Firstly, we enter the name, um, then the number, then the email address, and the password. Then we click on next. So we got a business detail. Here we have to fill our business details. Firstly, the name of your business, like I here I have Spice Villa. Then we can select its type. If you have GST number, you can add here, or you just leave it. So first I have, so I add here. Then you have two legal license of FSI. So otherwise you can't log in. So here's the FSSI license number, then the address, and just select the city, or enter the city, then select the state, and you can add on the password, pin code number of your area. Then just click next. You got upload documentation page. Here you have add only your Aadhaar card, PAN card, GST certificate, license, photo, and restaurant image with the menu PDF. So I'll just add here the image. Um, I'll show you the. I add single image because it's for demo. And you can add a minimum 10 to 15 MB uh, files in PDF. Then we click next. Here you can add your bank account details. Firstly, your account name, then the select the bank like SDFC, then enter your account number, confirm your account number, then add the IFCS IFSC ID, and if you have online transaction, so you can add here UPI ID, or just leave it. Then here comes the review. You can see your documents, you and extra details which you have uploaded, and you can edit it. Just then just click checkbox and register account. It shows the registration submitted successfully. uh, you uh, your documents will verify within 24 to 48 hours. This is the this is the exact same form your restaurant owner fill out. uh, Same API called underneath. uh, now now we goes on Prisma Studio. Here we open the vendor. You can see here the Rohan Mehta just shows the pending. See, here shows the pending request, and email, and then we goes restaurant tab. It sees, it shows, it see, it shows closed as a status. Um, Notice, even though the sign up is complete, this vendor cannot log in at. Let's prove that. Um, um, we goes in vendor module, login. Here you can see the email has here, and for our for sorry, for our convenience, I already add here the body. We just send it. uh, it shows failed because the ID didn't log approved by admin. The backend exactly rejects login until the admin approves the application. Then we goes approval. So we got in the folder of admin module. Then we goes in vendor management. Then here you can see, sorry, it shows uh, um, vendor list. It shows pending. It sends, is give us the ID. uh, we just copy it and then goes to approver. um, Here we need vendor ID. I'll just paste here and then send the I. It shows approved. Now these simulate the real admin workflow. Review the KYC document and then approve. When approved, two things happen automatically. The vendor status flip to approved, and their restaurant is switched from closed to open, making it instantly visible to customer. Uh, Now we goes in admin panel. Uh, then in the vendor part here, you can see approved, the same section, and admin clicking the button in UI, and the support agent using Postman for the bulk operator, both in the exact same backend endpoint. Um, Here the vendor approved. Then we goes in Prisma Studio, in a vendor table. um, you can see the status approved here. It is, see, vendor approved. Then we can just signing you first, firstly using APIs. Now I'll try once again. I'll change the password here and try to. It shows approved. Uh, Now login succeed. Notice we get back the restaurant ID. Every vendor action from here on is scoped to the one restaurant. Um, we goes in the vendor. Now we can uh, register signing easily. Firstly, I enter email, then password. After clicking login, you can see here the dashboard. The categories are organized in menu. Every product must belong to one. This requires authorized vendor um, with a vendor JWT and send scope to their own restaurant ID. So vendor can never accidentally add a category to someone else's restaurants. Um, then we can go in categories. We can go here and um, here we can add the categories. uh, so firstly we goes in create categories. Here I add starter as a name um, of category, and description approves um, and starters. After sending it's succeed. uh, then we just go in the front end and create category. See, you can see here after testing API, it's already here. um, then we we goes in vendor module. um, here you here we goes in the product. After that the add product. um, here we add the product which name is veg spring roll with the descriptions and the pricing of its crispy fried rolls of and veggies. This is the item a customer will eventually order. It linked to the category we just created, and the vendor restaurant. A unique SKU is auto generated on the backend. After sending this, it's also succeed, and we can goes in the product. um, it has error. It didn't show us the output because here some works are needed, so didn't show. But I'll show you the backend or Prisma in the product section. You can see here we just added those veg spring rolls with the price 150. It's SKU ID active now, ratings and etc. It's see here the timing or and the date. It shows everything. This product is now live. Let's switch the complete uh, switch hats completely and become a customer. Now we goes in customer part. Here we goes in or then just register as a customer. Here um, I, here I already add the name and the email address of the customer. Just send it, and the customer, or you can say the user created. Um, then just simple. It's simple self-serve sign up. No approval, no steps needed. Unlike vendor, password has the same way as the admin and the vendor. Then we goes in the front end. Here you can see the interface, but you need to sign up firstly. You can add here the same credentials which we added in APIs. Just paste here, and you can add your password and sign up. Oh, sorry. Some something goes wrong. Here you can see the row block. Now we goes in the customer table for checking. Here you can see the Anjali, but login. I just delete this for the. Sorry for inconvenience. Was I just um was the this is the public endpoint, no login required, and it should now show the exact restaurant product we just created a minute ago. has some problem. So, sorry for inconvenience. The WebSocket of app is crashes. So for further parts, we can go with the API testing. Um, uh, here we can directly go. Now we can directly goes with the API testing. I'll show you only test only APIs like the customer will order, and the order will created in create order. Here uh, just here user can select the paneer butter masala with the price 220 with the quantity 2. Just send it. The backend the backend calculates the subtotal, generate the unique order number, um, assign demo, delivery driver, and create the order with a status pending. It also broadcasts the live update over server, send events that water power real-time order tracking on the customer app. Um, here just we just Now we will just switch to the customer section, and now we'll discuss the customer with um, like a restaurant ID, but which we created. It will call from same restaurant. Um, it has menu items of delivery status, address, plans, state, pin code, and the note. Then because of the server class crashes, so I show you the orders. It didn't show because it fails earlier. I'll try it once again, but will happen. It shows the same. I'll just explain you what will happen. um, Everything ties together with the customer restaurant, product and order. All proper relation row, not loose JSON blooms. Uh, then then we can go in the order with the in the vendor module, and here goes in the order. Then we gets in the list vendor order. We got nothing because the API crashes. Uh, so it shows succeed. The endpoint will shows. Um, this is the to recap the full loop. An admin was seeded into a system. They approved a vendor KYC application. The vendor builds out their menu with the categories and product. A customer register and immediately show the exact menu, placed an order, and the vendor fulfill it, all flowing through one single Express plus Prisma plus PostgreSQL backend, export identically to Postman for testing, and the three real frontend for actual use. And at the every step, Prisma Studio lets us prove the data was correctly uh, precise and related to the database, not just display on the screen. Um, the further this is from my side. Now the future scope will be explained by my teammate. Over to you.
Although FoodMitra already offers a complete food delivery solution, we have planned several future enhancements. We aim to integrate voice assistant technology for hands-free food ordering, drone delivery capabilities, and automated enhancements. We also plan to integrate predictive analytics, AI kitchen assistants, IoT-based kitchen monitoring, and supply chain integration to make the platform even smarter and more efficient. With this, we come to the end of our demonstration on FoodMitra. FoodMitra is more than just a food delivery application. It is an intelligent platform that combines modern web technologies, AI, and data analytics to improve the experience for customers, restaurant owners, and administrators. We believe this solution can make food ordering more personalized while helping restaurants operate more efficiently. Thank you for your time and attention. Now, I would like to hand over this session to our director, sir, for his valuable insights and further proceedings.
In Axiom TechGuru, we transform ideas into scalable digital solutions with AI, innovation, and technology that drives real business growth.